Technically.
No, my bill, I know. I just, okay.
I'm gonna staple this to the back.
Yeah, that's what I did.
Back.
You're gonna be matching, so it has the same terrible face on it, and it's gonna be beautiful, and she's gonna love us forever and ever.
Alright, I just got confirmation.
He's gonna freak it out.
I told Shiloh.
Is this yours? Did you send it? Take it.
Looked up online. People like
But you can't pay me without this money.
one, so like it's easier to be oversized. That didn't really work.
Okay, ready?
It's gonna expire.
Did you put your $4? Yay! I'm so okay, so you, I technically only gave you $5 still, so
Bro, Fringe is literally the hardest.
This is like lunch that day, bro.
I got the dollar.
Have you ever took
On-
chemistry?
no, because
I don't know artificial.
Just got a D.
Guess that.
Bro, everyone said no.
I can let you keep my phone on your out, I guess.
Really pressured.
But I don't have anywhere to put my traffic thing, so I might have to back.
I just go, bro. I try.
You know, one match.
You want to be
Oh,
tested
God.
ready to activate.
Yeah, I'm so blessed on it, but it's
And we test tomorrow.
What's your first period?
oh, right.
So you haven't had any
That's it. So like, psych text.
I wish I took it.
So excited. Yeah. Rhetorical report. I don't think Miss Crossword tells us to do that.
It's not my fault. Because you are hand touching. It's not my hand. It was good. Not really. Because there's a lot of words. You need to read a lot. But for this class, it's just pure math.
Good chance for you, maybe.
Goodbye, Mr. Parker.
That's somebody in the back.
Nothing to, I mean, we're turning in 42. Unless you did it during 42.
You mean like, how we train that? Is it okay? Question.
Yeah, you're able on me too. So I'm gonna write every day and do sequences. Trying to do my corrections for everything. Got one of those. I don't see this.
Okay, wait, that's so bad.
Wait, that's correction.
He gave me a point for being off purpose. Really? You said it? I had an answer on my quiz. Or
It ruined my life, because last night I opened my race, and I saw that.
no, I was
Wait, can't we do this pizza?
we're not ready.
So most I can get, 14. You said you can turn it in, right?
If I was looking at that question and I can't figure out how to.
Wait, did you all get I have tons of like 3 questions.
Oh, because it got to the calculator part.
I didn't know what was happening. I signed up for 31 and then just screaming. No, so it was like shooting.
Okay, we are actually gonna swap these two things around here today. My first period class, I realized after we did it this way that the agenda says, there's a lot of people that were finished or very close to being finished with the alternating series work, so then they didn't have much to do before lunch, and then they were just not able to move on and do as much from the ratio test as I would have liked. So we will look at, do a quick little review and talk about 44 when we come back from lunch. But let's go ahead and start with the new stuff first. And again, we're only starting the ratio test. This is not one you have to finish or anything. But I'd like you to see it and see how it works. And then you can have the rest of class to finish up 44 if need be. I also didn't put this on the thing up here, but if you guys do finish, well, anyway, we'll talk about that after lunch. It's fine. Okay, so the ratio test is one of the ones that I kind of like, but it is pretty weird at first. In that the work is actually pretty similar to what I showed you on one of the alternating series examples last time, but this is a process that's going to happen more and more. So before I even tell you what the ratio test is and what you're testing for, there's a couple little reminders here. So this one on the top right, this one I think you should be a little more familiar with. If you have 3 to the n plus 1, consider splitting that up as 3 to the n times 3 to the first. I know I've recommended that to you recently, but that way you can see that stuff cancels correctly. So again, if you have a 3 to the n plus 1, consider writing it as a 3 to the n times 3 to the 1. When you multiply things with the same base, you add the exponents. You guys are used to going this direction, but we're having to go the other direction. The other one is factorial, and factorials will, I didn't realize it came up on the alternating series page, but you may just have not gotten to that yet. Factorials are one of those weird things that a lot of you just have never seen before, so factorials are going to start coming up a lot. 4 factorial just means 4 times 3 times 2 times 1, whatever that amounts to be. So how big would 5 factorial be?
Times 4 times 3 times 2 times 1.
120.
Good, 120. It'd be 4 factorial times 5, right? So same idea here. N plus 1 factorial is like n plus 1 times n minus 1. You keep multiplying by one less integer, n minus 2 to 1. And then n factorial is like n times n minus 1 times n minus 2 dot 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 to 1. So really all of this cancels except for n plus 1. N plus 1 factorial is like n plus 1 times n factorial, so then the n factorials can cancel and leave behind that n plus 1. But you do need to have a general understanding of factorials. Okay, so what we'll be doing is, so the condition for a ratio test is they need to all be positive terms. And assuming that's true, then what we will do, and again this should sound a little familiar, we're going to take the n plus 1 term, so everywhere there's an n we're going to replace with an n plus 1, then we're going to divide it by a sub n, which is the original series in the question. We're going to take the limit as n goes to infinity of that, and what's happening is I'm comparing a term with this previous term. If this previous term is bigger, then the denominator is bigger and the fraction's less than 1. And if each term keeps getting smaller and smaller and smaller, then that's how we're going to know it converges. If it's bigger than 1, that means that the terms are getting bigger, and if the terms are getting bigger, then eventually the sum of those terms would go to infinity or diverge. And if it equals 1, then we don't really know anything. You have to use another test. So it has the same purpose as all these other tests we've talked about: p-series test, harmonic test, geometric test, alternating series test. We're still trying to figure out if our infinite series converge or diverge. So this process, this won't be the last time you do this type of process too, so it'll be good practice for you in the future. But we're going to divide those, take the limit as n goes to infinity, and if it's less than 1 we can say it converges, if it's greater than 1 we say it diverges, and if it's equal to 1 it's inconclusive and we would have to use another test to get the answer. So to start off here, they give us 2 that we are supposed to know the answer to. What does this number 1 do? Is this
It diverges
okay? And how do you know that so fast?
because it's the harmonic series.
Good. So we know the harmonic series diverges, but let's practice the ratio test and see if it can do this for us. So the ratio test, again, it's kind of long-winded at first, but after you do 4 or 5 of these and you kind of get the hang of the steps down, then it gets quite a bit easier. You take the limit as n goes to infinity of n plus 1. So everywhere there's an n, you replace with an n plus 1. Divide it by a sub n, or even better, multiply by the reciprocal of a sub n. And then what does this limit come out to be? This should be the easy part. Infinite limit, degrees are equal, leading coefficient over leading coefficient. And if the ratio test gives you 1, what did we figure out?
Use another test.
Yeah, so it's inconclusive. So the ratio test could not be used to prove that the harmonic series diverges. The ratio test just doesn't do anything for us there. But it was also not that hard to apply. Okay, if we do the same thing on number 2. So again, I'm just going to try the ratio test and see what happens. So the limit as n goes to infinity of a sub n plus 1, which is a sub n with n plus 1 replacing n, divided by a sub n, or multiplied by the reciprocal of a sub n. And then I can see that this degree is 2, and this degree is 2, and this leading coefficient's 1, and this leading coefficient's 1. So I can see that comes out to be 1. If you need to take an extra step to FOIL this out, then I guess go ahead. But once again, the degrees are equal, so the infinite limit would be leading coefficient over leading coefficient. It's going to be 1. And unfortunately, when you take the n plus 1 term, divide it by the nth term, if it equals 1, we didn't learn anything. This is inconclusive. So if this was an AP test question, on your AP exam and it says figure out if this converges or diverges, there's nothing wrong with trying the ratio test, but when you get it equal to 1, you need to realize that that doesn't help you. You've got to try something else.
So then P-series will always be inconclusive?
That is correct, yes. These two examples, that's what it's trying to build up to be. If it's a P-series will always come out to be inconclusive for the ratio test. But again, that sounds like that was a lot of work for nothing. But again, I hope that you wouldn't do all that for that question. I hope that you say it's a P-series, P is 2, 2 is greater than 1, so we really know that it converges because we know other tests. But based on the ratio test, it would be inconclusive. Okay, so here, the next two are more in line with the level of difficulty that you should expect. Much more complicated looking. And again, it's not that I'm now saying, and this is going to be true for the last few lessons we have, I'm not saying that you need to start doing the ratio test every single time. Try to take the easier way out. If you see it's harmonic, say that it diverges. If you see that it's a P-series, just use the P-series test. If you can tell it's geometric, just use the geometric stuff. That's easier, it's quicker. But if you're not sure what else to do, it might be at some point easier than your other options. Like I would not want to try to integrate that. In fact, that's not integratable, so I can't even use the integral test. So I could try the ratio test, replace all the n's with n plus 1s divided by a sub n. And I'm going to stop saying this, but I'm just going to multiply by the reciprocal of a sub n. And then we want to cancel out a lot of stuff and then do the limit. Now, I did this purposely. Remember at the top of this page I talked about the simplifying. So I'm going to leave the n plus 1 squared alone, although you can FOIL it out if it makes you feel better. This 3 to the n plus 2 though, I'm going to write that as 3 to the n times 3 squared. Instead of saying 5 to the n plus 1, I'm going to call that 5 to the n times 5 to the first. And then 3 to the n plus 1, I'm going to rewrite as 3 to the n times 3 to the first. And again, you really want to do that because it's going to help you cancel stuff out much more accurately. You've got a 3 to the n that reduces, a 5 to the n that reduces, you've got a 9 that could cancel out this 3 and leave behind the 3. And then in the end, my numerator is a 3 times an n plus 1 squared. And my denominator is a 5 times n squared. So you can choose to FOIL this out if you want to, but it's going to be degree 2. This is degree 2. So leading coefficient over leading coefficient, 3/5. Is 3/5 my answer? No. Nobody asked for the number. It's the fact that this is less than 1 tells you that that original question diverges. Now again, at a quick glance, that work looks super complicated. It looks like I'm doing a lot of heavy lifting there, but if you, after you do it a few times, you're going to be pretty comfortable with that process, I think. Okay. Do you have something specific about 3 to ask, or are you guys ready for the next one? Yes?
If it's less than 1, doesn't it converge?
Yeah? What's the problem? Did I say it wrong too, or just write it wrong? Okay. Yes, it converges. If it's less than 1, it converges. Sorry if I said it backwards. I definitely wrote it backwards. Okay, that was a good question. What else? How come nobody else said anything?
Well, I'll still writing down.
The rest of y'all are in trouble. Okay, you ready? Okay, so let's try the limit comparison, not the limit comparison test, the ratio test here. So 4 to the n becomes 4 to the n plus 1, And I'm going to save myself a step from the last question, and I'm just going to change it to 4 to the n times 4 to the first, because I know I'm going to need to do that in a minute anyway. If I replace n factorial with n plus 1 factorial, again, just like the top of this page, I'm going to change that to n plus 1 times n factorial. And the way I know to do that is from experience. Now when I divide by a sub n, I saw that I was going to want to cancel those out, and that's why I wrote it that way. And then these cancel out. And then a lot of times, this one's not as bad as the last question, but a lot of times you get a lot of simplifying here, a lot of confusion. So you probably need to like write the survivor part of this before you say what the limit goes to. And what would this limit go to?
0.
And since 0 is less than 1, it
Diverges. And converges, or diverges, yeah. No, convert. Huh? Wait. Yeah, converges.
converges. There you go. If it's less than 1, it converges. If it's greater than 1, it diverges. Because, again, think about what you're doing here. I know that you're just like doing some steps and then comparing the numbers. But if you're taking the n plus 1 term, you're taking some random term, or any term really, because it's generic n, and when you divide it by the previous term, like if this is a 2 and the next term is a 4, if you take a term, the n plus 1 term, and divide it by the previous term, the nth term, then you can see like how this is changing. This is increasing by 2. If it's always increasing by 2, each term's getting bigger, and if each term keeps getting bigger and you add them all up, then it's going to go to infinity and it's going to diverge. But if these are switched, and a term divided by its previous term is something less than 1, then each term's getting smaller, and you're adding smaller and smaller pieces together, which means that it could converge. So it's helpful if you think about that. Okay, and then, okay, so one more example, and then I'll ask you to look at 1 or 2 of these, and then if you don't have time to get to this the rest of the day, that's fine, but okay, so this one has a pretty common mistake in it, and that the process is still the exact same thing. I'm going to still do the ratio test, but notice, make sure you don't fall into this trap. When I make n plus 1, I don't get a 2n plus 1 factorial. If n becomes n plus 1, 2 needs to be distributed to both of those, so it's a 2n plus 2 factorial. Okay, divide by a sub n. I did not feel comfortable simplifying on the fly here, so I'm going to try to simplify this, and I know that it needs to cancel out with some of that. So out to the side, I'm going to think about 2n plus 2 factorial is like 2n plus 2 times 2n plus 1 times 2n plus 2, or I'm sorry, 2n times 2n minus 1, and all of this stuff is the same as 2n factorial. So this can cancel out this and leave behind just these two. Okay, I don't want to multiply the numerator together, but if I did, what degree would the numerator be? Right. If you FOIL this out, you're going to have like n squared stuff, and then when you multiply this in, it's to the 7. Well, when the degree of the numerator is bigger than the degree of the numerator is going to grow faster than the denominator. So this limit equals what?
0.
0?
Oh wait, no, infinity.
Yeah, if your denominator is getting bigger, your fraction goes to 0. But if your numerator is growing faster, then your fraction just keeps getting bigger and bigger and bigger. It goes to infinity. So this, well, infinity is obviously greater than 1, so it diverges. So again, that was on the more complicated side, but really all that can make it a little bit harder here is some of this limit stuff, and the limit question at the end could be a little tougher, I guess. The simplifying of something like 2n plus 2 factorial, knowing that that's the same as 2n plus 2 times 2n plus 1 times n factorial, so you can, or 2n factorial, so you can see those cancel. But that's about the only way that you can step up the difficulty there. Okay, so I have a couple of questions I would like you to try first, and not necessarily question 1. Actually, go ahead. I guess just 1 and 2 is fine. Try 1 and 2 just for some quick feedback. I'll share the answers and go over those 2 with you. And then that might be all the ratio tests we do for today. Again, I'll go over them once I think you've had time to try them both, but I did jot the 2 answers on the board for you to quickly check. So, if you feel good about those and you got them right, then you can maybe do another question or something lightweight.
Wait, if either the denominator or numerator has a factorial and nothing else it has n like factorial and nothing else, and the other one doesn't have a factorial, don't we just know from the beginning? Because it sort of outweighs all the other ones. So like for this one, you can tell it converges because it's in the bottom, and you can tell the right one diverges because it's in the top.
Right, so to me, if just because I've done a lot of these, I can glance at these and I know how the numerators and denominators rise, like you're talking about, and factorials grow even faster than exponential. So yes, on question 1, I can tell the denominator's growing faster, which means it's probably going to converge. But you have to keep in mind that's not a blanket rule. The harmonic series 1 over n, the denominator grows faster there too. And it diverges.
Well, but in this case, it's specifically because it's a factorial. That's what I'm saying. Because on the front, yeah.
So for the second question, I would feel much more confident in saying that diverges, because I know n factorial grows a lot faster than 5 to the n. So yes, if you understand that relationship and how fast things grow, then you can often have an idea of what to do. But you need to practice the ratio test anyway, because you're going to have to show that work for FRQs. So. does anybody want more time for these two? Okay, so if you did not get 0 is less than 1, so it converges, you need to see what changes you need to make. So the ratio test, you guys know ratio just means something divided by something, right? That helps you remember that it's n plus 1 divided by n. So if a sub n plus 1 would be n plus 1 times 3 to the n plus 1 over n plus 1 factorial divided by a sub n. And then again, canceling out carefully, 3 to the n's are going to reduce. These can almost reduce, so you need to think of n plus 1 factorial as n plus 1 times n factorial, so that you can get the n factorials to cancel. And then it's probably going to look super messy, and you need to be careful not to jump to the answer too fast. Looks like I've got a 3 times an n plus 2 in the numerator, and n plus 1 and an n plus 1 in the denominator. So the degree of the denominator is bigger than the degree of the numerator, which means the denominator is growing faster than the numerator. And in a fraction, when the denominator is growing faster than the numerator, the limit goes to 0. Since 0 is less than 1, it converged. All right, any follow-up to that? That one okay? Okay, then for number 2. So honestly, like, and this is not a bad idea, I've not said to you guys, but as you do more of these, it's not a bad idea to look at this and try to think about what's going to happen. I'm not saying jump to an answer or flip a coin and hope that it's right, but sometimes if you can tell the numerator is growing faster than the denominator, meaning these terms just get bigger and bigger and bigger, if the terms just keep getting bigger and you just keep adding them together, it's going to go to infinity. So looking at this, I know factorials grow faster than exponential, so I know it's going to happen. So I'm 99% sure this is going to diverge from the beginning. Now, it's fine if you're wrong, but I do think it's worth, kind of looking and just seeing if you can make an educated guess about what's going to happen, because a lot of times with your number sense, you can be pretty right, or right often. Okay, so if I rewrite this as n plus 1 times n factorial, then it's got this n factorial to cancel out. If I rewrite 5 to the n plus 1 as 5 to the n times 5 to the first, you can see the 5 to the n's cancel out, and you're left with the limit as n goes to infinity of n plus 1 over 5. So this goes to infinity. Infinity is obviously greater than 1, so therefore that infinite series diverges. Okay, any final thoughts about number 2?
No.
Okay. Now, I would love for you to do more of this today, but the priority is finishing up our assignment from last class. So, last time we talked about the alternating series test. So, you should spend a couple minutes looking over what an alternating series was and how to know if it converges. Ultimately, alternating series have a piece of the series that makes it alternate between being positive or negative. Sometimes it's with trig functions, sometimes it's with -1 to the n or -1 to the n plus 1 or something like that. And then for an alternating series to converge, there's 2 things you have to test. You have to make sure the limit of base n goes to 0. And you have to make sure that each term is closer and closer to 0. that's where I basically was doing some of this on that. If I take it, the n plus 1 term divided by the n term, I can compare to see that if they are getting smaller. That's basically what it is. I'm gonna switch this back. So again, we did the second part of the agenda first, just so that people who were done with 44 could spend more time on 45 and stay caught ahead and not just stay here and wait. But your priority is finishing up 44, turn it in as you finish. You have all after lunch for that. If you have time to work on 45, that's great. When we come back from lunch, I will also pass back your recent quiz and talk about the corrections for that. But I don't want to do that right now because I don't want to distract you from staying on task. So just make sure you remind me if I don't think about it since it's not on the agenda. Gosh, I got something stuck in my throat. Can't get past it.
Yeah, probably.
Not my pencil. Get your pencil?
No. Oh, here's my test.
Ooh.
The one that's a 14 out of 20.
Wait.
Wait, this was
just
this
an
was
X.
polar. This is polar.
Oh.
Mine was polar.
I got really excited.
What's your?
No, this one's 8 out of 10.
Not even an explanation of why.
This one makes sense because I thought it would be that when I thought about it. Do you remember when I was thinking about it really hard?
Oh, I didn't even do that one right either. We talked about this when we were walking out of class. I also got this one wrong.
I feel like I'm gonna kill myself.
Oh, at least the one I didn't cross out the right answer. That's a win. That's a win. I'm already halfway there. I got 2 questions wrong. Okay. Each question was 2 points too. Almost.
So close. This class keeps hitting me up. Oh, look at that.
Wait, I was.
Change the score.
Amy, you were so excited. It went
Wait,
up
I
to
was
14.
Close.
So close. You know what? I count that as a win. This is a win.
What's a win?
My series.
It's okay, yeah, I thought I got a 4.
No, it is such a win. That's hilarious.
No, it
I
was
also got
actually so
over
sad.
two
That's so much harder. No, I was surprised.
Yeah, I see, I did. Yep.
Okay, first thing I'd like to look at is see if you guys have some questions from the alternating series that you were working on before lunch. So let me take those from you first, and then I'll give you some information about the corrections and stuff. Sorry, my ears need to pop or just popped or something. Okay, what questions are you having from the alternating series test? Okay, so that's still going okay? Okay, that's fine, if that's the case. So I do need you to finish that up first, so prioritize 44 for me, please. I do want you to turn that in with your name on it. After that, you're welcome to start on your corrections if you'd like to. So I actually passed back 2 quizzes to you. I meant to pass back the other one more recently, but the one that says Unit 5 quiz, there's no corrections on that one. The average on that one was much higher. But the recent one, the 10-1 through 10-5, so you can earn half of your points back if you go back over the questions you missed and write on a separate sheet of paper how to solve those so that I can see that you learned from your mistake, and I'll give you half your points back. I don't want you to turn that in last minute during the semester, but short of that, I don't have any specific deadline. So I think it's probably good if you do it early, because it's probably mistakes with the nth term test or a mistake with the geometric series, things that we are using now, and so sooner you realize what your mistake was, probably the sooner it will benefit you, but I will leave that up to you. Okay, so finish 44, turn it in, start on your corrections if you want to. If you're happy with your score, or if you got all of them right, then of course there's no benefit to doing corrections if you got them all right, I guess. But if you only miss like a point or two, you may not want to do corrections, which is fine. That's your choice. But don't do that until you have 44 finished, please. And if you did great on those, then you can make some more progress on the ratio test. Again, the ratio test is not due tomorrow. I will see you guys again tomorrow. It's a B week. It's not due tomorrow, but the more you get done of it today, the less you'll have to worry about it tomorrow. So it's still in your interest to get as much done as possible. Okay, for the most part, it seems like y'all are doing fine with the alternating series, so I'm not going to bug you as much here, but you guys need to tell me if there's something in there you want me